Alright, CNT140, we're continuing our discussion here on Chapter 4. We just got done talking about the first part of things here. They said terminations are connected with plugs and jacks. So we took a minute and talked about outlet jacks and terminations for your solid and stranded cabling. Now we move on to the section where they talk about punchdowns. And they remind us about punchdowns, and they also remind us about patch panels. Alright, well, let's break these out just a little bit. The first one they talk about is the 66 block. This has been the termination block and the workhorse for phone wiring for quite a long time. Here is a close-up of a 66 block right here. Here would be what it would look like in an actual commercial network or a business where you literally have a whole wall of 66 blocks. Real quickly, the phone wiring from phones around the building come in and get terminated in this block, and then wires come from the other side of the block up into your phone system or your phone switch kind of thing. That's the kind of thing you have going on. This has been a termination block for phone for a long time. If I look at a diagram of what I see, I typically have our PBX. You can think of it almost as like a phone switch, and you have a large bundle cable, 25 pair cable, that goes from there and plugs into the size of the 66 block. And this would terminate all the phone lines coming from the PBX into a 66 block. So basically 25 phone lines. This might be on the first floor or the basement of the building. You would then have a 66 block maybe up on like the first floor or second floor of the building, and phone wiring running out to outlets in rooms of the building. What having these two 66 blocks allows you to do is use a cross-connect wire from the block up here on maybe the second floor down to the block in the basement of the first floor. This ends up being a cross-connect to allow you to connect those two phones together. That way, this can stay connected all the time, this can stay connected all the time, and as people move around, you know, Doug moves to a new office or Doug gets fired kind of thing, this can be, just this cable here can be disconnected and moved to a new location. You know, if Doug gets promoted and moves to a new office, takes a new job title, gets a new phone number, this might need to get moved to a new location, that kind of thing. That's what this allows you to do, the 66 block. Big termination block for phone. One of the problems with it, though, if I back up and look at it here, these terminations really require a lot of wire and twist to do it. So this was good for, 10 megabit, barely into 100 megabit bandwidth for data. So this was primarily used for phone. The other termination block they talk about is a 110 block, this guy right here. We're going to see shades of this when we move into terminating on the patch panels. So the 110 block, again, was originally designed for phone, adapted into data, and was used for data for quite a while. Here is a kind of a close-up of the block itself and a little connecting clip that goes on top. And terminations end up being like so. Kind of like your horizontal wire comes in here and gets terminated in the bottom, connecting block gets snapped on top, and then this ends up being the patch cable going into a switch or something of that nature. What we find, though, is if I back up a little bit here, here's our block on the wall, all the phone wires come in and get terminated in, and then I can patch from here into other stuff. I still have a bit of untwist, but this could be done a lot cleaner, that I could get into 100 megabit networks, but again, still, the amount of untwist on these did not get us into modern network bandwidths, if you will. But what I do notice is I start looking at this little connecting block clip here. This ends up looking like the back of our patch panel. Exactly. This came, the idea of termination of the back of a patch panel came from this 110 connecting block clip. That's where that came from. So as I move into patch panels now, what I find is that 110 block termination here on the back, my horizontal cabling comes in and terminates to here, but on the front, instead of having another punch down or another termination, I have my RJ45 jack, allowing me to plug and unplug patch cables for easy, flexible connecting, disconnecting cable runs, network drop set sort of thing. So our termination block of today for choice is the patch panel with the 110 block in the front and RJ45 on the front. That's what, and if you kind of look back through, 66 block for phone, lots of untwist, 110 block for phone and eventually data a lot better. Termination, a lot less untwist, lot less chance for crosstalk interference. That piece of the 110 block then gets incorporated into the patch panel that we use today. So it's kind of an evolution thing, and that's why they talk about those other two blocks first, mainly for familiarity for you, but to realize the patch panel, what we have today, where it kind of came from. Real quickly, while we're here on the patch panels do come in 12, 24, and 48 port. That's the common. They do make 96s, but those are kind of the common ones, 12, 24, and 48. And it's no coincidence that switches are sold in 12, 24, and 48 port count switches, if you will. These patch panels and switches are designed to kind of work in as a pair. I remind you again, while we're talking terminations here, the terminations on our patch panel, according to our standard, 568 standard, half-inch untwist for these terminations. So I need to maintain twist up to that termination as much as possible. Here, they also remind us, as they're talking about these different termination blocks, all connections are wired straight through. Well, again, if we go back to the diagram I had for you before, when we talked about horizontal cabling and we talked about patch cables, you'll notice I have a little piece in here that says wired straight through. Yes, all of our terminations for our 568 system, patch cables and horizontal cable, are all wired straight through. What that means, the book talks about having things wired pin 1 to pin 1. Absolutely. Pin 1 on this end is wired to pin 1 on the other end. This whole system is designed for a user, a computer, to hook up to a switch port, if you will. That's what it's all designed. So all this needs to be wired straight through from user here, Nick, the whole way through, patch cable, horizontal cable, patch cable, into the network port on the switch, or the switch port, if you will. So, what they mean by wired straight through is, I would use, in this case, my 568B, that's what we're seeing here, 568B color code on, N1 of my cable or cable run, and I'm going to use 568B on the other end of the cable or cable run, so that everything is wired straight through. If I were to mix match my color codes, which is relatively easy to do, you do patch panels all on one day, maybe you do all the patch panels on Monday to 568B, and you got to start doing outlets, and you forget on Tuesday and start doing the A color code over here. It's like, oops, you're creating crossovers. That's easy to do when you mix match your color codes. We don't want any terminations in our system here to be crossover. We don't want any to be crossover. So make sure terminations are all straight through. Make sure you're following that consistent color code the whole way through. The other thing they remind us about is good cable management. Absolutely. They make lots of cable management products. Here is a wire management panel that would go in our distribution rack. I give you a picture of a distribution rack here with some wire management panels in, horizontal as well as vertical. They make vertical ones too. And that is there that I can do this right here. Bundle my cables, organize them, and have them supported and organized on our equipment rack. That way it's nice and organized. There's no stress on the terminations or connections. Troubleshooting becomes easy. Along with that, reminder, don't forget cable labels. Good cable labeling on the cables, patch cables, horizontal cables, everything. That aids with troubleshooting and tracing through problems. Otherwise, I end up with a mess like this. And actually, this is a couple different equipment racks here with all these cables looped everywhere. And there's even a little work light here. That's a little electrical work light hanging there. Kind of crazy with a little sign that says, don't touch any of these. That's kind of nuts. This is what we're shooting for. We're shooting for organized bundle cables coming in. I can trace a problem. I can find a problem very easily. They remind us in here that terminations can be done in all kinds of combinations. I'm going to remind you that more times than not, we're shooting for the standard install, patch panel out to outlet. We will talk later about MUTOA, multi-user telecommunication outlet assembly. The standard actually gives us guidelines on how to do that. So there is things in the standard to allow exceptions to the rule, but more times than not, we're going to do this. Patch panel, horizontal cable out to an outlet, keeping close eye on our 90 meter max distance here for horizontal cabling. As I go to a second floor, my structure is going to basically be repeated on a second floor. Very hierarchical, very modular approach. And again, here's a multi-floor picture that we're used to seeing. That's what we're shooting for more times than not. They then take a section here and remind us about Power over Ethernet. Remember, Power over Ethernet, we can actually supply power in the unused data wires to a device on the other end. So things like access points, IP cameras, IP phones can all be powered through these unused data wires. And that allows for placing access points where they're needed for coverage, not near an electrical outlet. That allows for phones to be placed on your desk and powered from the switch. And if there's a power outage in the building, the switch is still powering the phone for emergency 911 phone calls. Very important. So Power over Ethernet allows that to occur. Here is a smaller Power over Ethernet switch, and as I look at it, it even tells you these ports are powered, these are not. Larger switches start telling you the same thing. Some of them, as you get to larger switches, will even show you what ports are actually doing Power over Ethernet on them. You'll see a link light, then you'll also see a separate link light showing you which ones are powering. If I look up the specs on some switches, and I just pulled up a search on a Cisco workgroup switch, a 3650 workgroup switch. If I look up the model numbers, I'll see there's a 24 port, 48 port, etc. As I come down here a little bit further, I see a 24 port Power over Ethernet. It even shows me the wattage capability of that. So they make different model numbers, and some do not have capability and some do. Some have a small amount of wattage, some have a large amount of wattage. And obviously these are going to cost more than a regular, and these will cost more than a basic Power over Ethernet. Why I'm mentioning all that is, on a switch like this guy here, as you look up the specs, if it can support 390 watts, it basically can support phones on half the switch, because these kind of phones here draw around 15 watts. So that would mean I can, as I do my math here, I can support phones on roughly half of this switch. As I start to try to plug more switches in, this does not have the power to do it, so these phones will not power on. So as I'm dealing with Power over Ethernet, the book talks about it, yay, but you do need to look up the specs on the switch, what's it capable of, and then what devices am I plugging in, what wattage is it using, so I know how many of those things I can plug in. That goes for access points, cameras, phones, whatever. Also, a reminder, in my equipment or my cable trays, these cables should be well ventilated, using a basket type tray like this with open sides, and making sure the cables are not piled in there full allows ventilation around those cables so they don't get hot. That's key. The cables start getting hot, you start having data loss, etc. They remind us of balloons, B-A-L-U-N-S, balloons for connecting older cabling to newer cabling, coax to twisted pair. Not so much we encounter anymore, but that is a piece of equipment to connect older cabling to newer cabling to worry, have the not worry about the impedance mismatch, if you will. They mentioned at the end of the chapter about fiber optic. There is options in our standard for fiber optic to do a fiber infrastructure. Well, we're kind of used to seeing that. I pulled this out of the standard. We're kind of used to seeing in this concept right here, using fiber between the floors and then horizontal cabling out. That's kind of what we're used to seeing. That's roughly the idea what we're seeing here. Okay, so not too much different than what we're used to. And they also remind us too in this, they talk about different connectors for fiber. The standard actually says any, I don't need a special type, but any kind of duplex design may be used. And that means I have a couple different types of connectors here, SC, ST, FC, LC, that are allowed to be used. And the standard basically only says they need to be of blog grade or better, X amount of insertion loss or better, if you will. What is most common right now is this type of LC connector right here, this duplex connection. This is pretty much the most common one you run into for the SFP modules and outlet jacks and those kind of things. This is the common one right now. That might change in a couple years, but that's where we are currently, the LC fiber connector. And that's roughly the end of the central or the standard install of cabling in our building.